So we've got two of our ingredients. We've got that iron ore and we've got our coal. Now we need to put them together into our oven. In this case, a really big oven, a blast furnace. The blast furnace gets its name from the blast of air that is forced into the base of our fire, air containing oxygen that allows the coal to burn hot enough to actually melt the ore. If we want to get the iron out of that rock, we literally have to liquefy it. This is like making lava. This fire approaches around 3,600 degrees Fahrenheit. That's an incredibly hot fire. I wouldn't want the job of dumping fuel into the top of that furnace. The way that our blast furnace is powered depends on how big it is. Blacksmiths also have to force air into their fires, and a blacksmith's forge is small enough that they can turn a crank and blow air into their fire, or they can operate a bellows, which you may have seen before. That's a large sack that can blow air into a fire. But our our blast furnace uses water power. The canal is at a higher elevation than the river, which is nearby. The water dropping from the canal and passing out into the river has enough energy to spin the turbines that would power our blast furnace. Now, it's not enough to heat up the ore by burning the coal. We've liquefied the rocks, but this doesn't actually separate them. In order to separate the elements of oxygen and silicon from the iron, we need one more ingredient, and that's limestone. Limestone is a sedimentary rock, and it's another fossil. Much like the coal, which came from the fossilized remains of trees, this is the fossilized remains of sea creatures that lived right here, but even earlier than those swamps. About 315 million years ago, this area was actually below sea level. There would have been a warm, shallow, tropical sea right here where I'm standing. And in that sea, there would have been coral reefs, and there would have been a lot of microscopic organisms that were growing and living and reproducing in that water, and they had calcium in their bodies. And when they died, they settled on the bottom of that shallow sea, and they were buried under sediment. And much the same way that carbon in coal was concentrated by heat, time, and pressure, the calcium in those sediments was concentrated by the same forces of heat, time, and pressure into limestone. And you know what? This limestone is still rich in calcium. The calcium is still here. The calcium in the limestone acts as a flux. The silicon in the iron ore bonds with the calcium in these rocks, and it separates from the iron. The iron is very dense, and it sinks to the very bottom of our furnace. It's the only thing down there at the bottom. It's separated from the other impurities, which has been our goal all along. The limestone and those other impurities are floating as a separate liquid that is less dense on top of the liquid iron. And because it's floating on top, it can be skimmed off and separated from the iron.